Hello everyone, I am Rekha Murthy, Assistant Professor from Department of Electrical and Electronics Engineering from Sai Vidya Institute of Technology. Today I am here to explain the experiment related with the cycle 2 of Electrical Machine Laboratory 1. The experiment is voltage regulation of an alternator by EMF and MMF method. So here in this experiment, we are going to see that the regulation of an alternator can be determined by the various methods. What are those two methods? That is EMF method and MMF method. So here the EMF method, this method is usually requires some data to calculate the regulation. That is why we need to conduct the two tests. One is open circuit test and a short circuit test. From the open circuit test, we can bring out the characteristics, which is nothing but the open circuit characteristics, which are the graph of open circuit voltage against the field current. So this can be possible by conducting an open circuit test. And even the short circuit test, from the short circuit test, we can obtain the characteristic, which is nothing but a graph of short circuit voltage against the field current. So the alternator is usually, it will be coupled to a prime mover, which will be capable of driving the alternator at its synchronous speed. Here the armature is connected to the terminals of a switch, and the other terminals of a switch are short circuited through an ammeter. And the voltmeter is usually connected across the lines to measure the open circuit voltage of the alternator. Now let us see that to conduct this test, as in the previous experiment, what we had taken up the setup, the same setup we are going to repeat. The test is we are going to conduct a test onto an alternator. So nowhere we are going to make use of a transformer. So let us see that what are the equipments do we require. So these are the equipments we require. So it will be almost similar. The thing is the transformer is missing because here onwards we are going to conduct a test only on the alternator. So we require a generator motor setup and the resistive load. Okay. Apart from that, we require a rheostat which is of 600 ohm and voltmeter and ammeter. Right. So here, what range you have to use. So before we decide with this what range we use, we should know the nameplate reading of that. Then only you can judge. So we require an ammeter. So the ammeter usually we are going to connect it onto the alternator side. So on the alternator side means the alternator specifications you have to consider. How much it is. Rated output of a machine is 16 ampere. So better that we can choose as 10 amperes. 10 amperes. Okay, 10 amperes of a ammeter we require. And usually it is a 3-phase. So the voltmeter we require, that is of 600 volts. Okay. Then one more thing, that is we require we require also the DC ammeters, which is preferable on the board itself. Okay, so these are the components we require. So an ammeter which is of 0 to 10 amps and voltmeter 600 volt, rheostat 600 ohm itself, and we require an additional load. That we require it when you're going to conduct the we need to find out the resistance of the armature. So that time we are going to make use of this resistive load. Right now we require only these equipments, these 4 setup. Okay, so let us concentrate on to that. So as usual, we are going to prefer the DC shunt setup. We have to connect it, and this motor is driven. It is started by the 3-point starter. So LFA, L is connected directly to the line. That is of DC voltage, which is of 220 volts, and F should be connected to the rheostat, which should be in a cutout position, which is of 600 ohm, and in series with a field winding. and armature is connected to the motor. And the alternator here, we are connecting between the U and V terminals. So all these three terminals will be utilized here because we are conducting a test on the alternator. So since we are finding three terminals we have to utilize, so definitely we require one switch, that is triple pole single through. Triple pole single through. So we require the TPST switch, right? So with this judgment, we require one TPST switch also. So in the components required, you have to make use of a TPST switch also. In addition to that, we require the two ammeters. Okay, one is in between the U and V terminal, and the another one we require the U, V and W terminal, which is of the range of a 0 to 10 amps. Why do you prefer that? Because the specification of this ammeter of an alternator current, that is rated out current, is only 16 amperes. So we prefer the 10 amps, which will be more preferable. And also, in addition to that, the DC supply should be given to this rotor, where a DC ammeter should be utilized. Now let us move on to the test. Before that, I can just show you that this is the setup where we are going to conduct an experiment, and you can see the equipments which I have taken up. I require a 600 ohm rheostat and the two ammeters. Okay, this is the one first ammeter, this is the second ammeter, and one TPST switch. This is what TPST switch it is. And this setup is almost similar as we discussed in the previous experiment, what we had done. The same setup we have to take up. So this is for the connection as usual. The positive is connected to the line, and the rheostat is connected to the field, and the other end of this, the rheostat should be connected to the Z, and ZZ coming back to the negative supply. So this completes a one closed loop of this, a part of the field winding and the line. Next, coming to the armature side, the armature terminal should be connected to the motor, and the other end of this AA should be connected back to the negative supply or to the ZZ. So this completes your DC shunt motor connection. Coming to the alternator, the U should be connected to the triple pole TPST switch. So red should be connected to the red terminal of this. So that is U. And coming to the V, it should be connected to the another terminal of a TPST, and W is connected to the another end of the TPST. Similarly, the other end of this TPST switch, that is the beginning, the first one, should be connected to an ammeter. The other end of the ammeter, which we have to prefer 10 amperes, should be connected back to the other terminal of the output of a TPST switch, the other side of the TPST switch. And the other side of the same TPST switch connection should be interconnected with the another ammeter, and the other ammeter should be connected back to the other side of the other end of the TPST switch. This is how we completed a closed loop. Now coming to the rotor side. So we completed the stator connection of the alternator. Now coming to the rotor. Positive supply should be connected to the field, and the other end of the field winding should be connected to the ammeter, DC ammeter, and the ammeter other end should be connected back to the negative supply. This is how we completed the rotor connection. Next, coming to the voltmeter insertion. Voltmeter is connected across the U terminal, and the other is connected to the V terminal. This is how we complete the connection. Coming to the OC test. So the circuit is rigged up as what we have shown here, with the SPST switch open. With the SPST switch open, and also the TPST switch is open. Okay. Now we have to switch on the supply. The supply is closed, and the speed of the motor is brought to its rated value by first moving this 3-point starter, and make sure that this rheostat is in cutout position. And by varying this, that is by varying this rheostat, we can make the motor to run with a rated speed of 1500 RPM. After once it is achieved, what we have to do now? Now the alternator should be the alternator field is excited by closing that SPST switch. Now you have to close the SPST switch. Now, by varying this thermostat in a clockwise direction, the generator voltage is increased. The generator voltage should be increased in the steps of 50, 100, 150, like that. Okay, it will be increased with the in steps of this. Make sure that during the OC test, this TPST is opened, not closed. We have not in contact with this, okay, with the ammeter. So it is still opened. Only that we have to close the SPST, vary this thermostat with the range of with the steps of 50, 100, like that, and corresponding values of the field current should be noted down. That is this one. Okay, corresponding field current should be noted down. So this is how we, with the help of these two readings, we can draw the OC characteristic. Okay, that is how 50 up to in the with the steps of 50 up to 400 volts we need to vary. Then by varying after that, bring back the thermostat in a minimum position. Then off this SPST switch is opened. Then bring back this rheostat in the cutoff position and switch off the supply. This completes your OC test. Coming to the SC test, with the SPST here again we have to switch on the supply, and DC motor is started with through the DC starter, and vary this rheostat such that rated speed is obtained. Then after that, close the SPST and close the SPST and as well as the TPST switch. Then vary the thermostat such a way that both the ammeter will read around the 7 ampere. That is a rated current. Okay. How to find out the rated current? Since it is a 5 kVA alternator, so 5 kVA divided by 5 kVA divided by the 3 times of 415 when you solve. Okay, so we 5 into 10 power of 3 divided by 3 times of 415, we get the value of the current. So that leads to the 7 amperes. Then the we have to vary this thermostat until you get the 7 ampere. So the field current, the corresponding field current, only one reading you have to take down. Okay, the corresponding field current which is required there to circulate the rated current is noted down. Then after that, bring back this thermostat into the minimum position and open the SPST switch as well as a TPST switch. This is how we have to switch off the DC motor. Okay, so the readings corresponding during the SA and OC test should be tabulated. So this is how we can take down. After that, we require also the measurement of armature resistance, which is one of the parameter when we are going to solve the voltage regulation formula. So in this test, you can see that we are going to utilize the DC supply here, which we have to connect it with the DC of the ammeter, and we need to measure the the stator winding, that is this stator and this stator. We are measuring between the U and V. So these two resistance will come, it will be in series. Okay, so therefore you can write this will be of almost 2 times of series. So it is RA plus RA. It is a 2 times. So that is why we get a formula RA is equal to V divided by 2 times of I. So here also this is the connections which you have to make, and vary the apply switch on the supply and vary the resistor bank load of a 2 amperes, 2 amperes, 4 amperes and 6 amperes, and the corresponding reading of a voltage and current should be noted down so that we can solve this resistance, armature resistance. So average resistance value should be taken down by taking an average of the 3 values. Okay, so this is how we can measure the effective value of the armature resistance. So this armature resistance will be utilized in the case of the voltage regulation formula, and this is what the specimen graph which will get it when you solve the characteristic. And to solve this, percentage regulation is usually given by E minus V, that is no load minus full load divided by the full load voltage. So wherein the E naught formula is one of the biggest task which you have to solve that is the square root of V into cos phi plus I into RA whole square plus V into sin phi plus or minus I into XS whole square. Plus is for the lagging, minus for the leading cases. So with all these cases, we have to we have to solve it. Okay, for the different power factors, all the three power factors, then only we can plot this type of a graph between the percentage regulation and different power factors. And here, how to get this RA value? You will get it from the previous the slide which we have solved, the average value of RA. Then how to get the XS value is, there is one formula ZS which is equal to E, that is open circuit voltage, divided by the short circuit armature current. So this ZS is nothing but it will be the value of the AC, that is this value AC divided by the AB value. Okay, so this value will give you the ZS, and XS that is nothing but a synchronous reactance which can be solved by square root of ZS square minus RA square. So we can get the value of XS. So this is how we can get we can solve the regulation. And coming to the MMF method, the both the procedure it is almost similar. Only the thing is we will solve in a different way. We have to find out here IF1 and IF2. Okay, two field currents, we have to find it out with the respective voltages. So this method is mainly based on the assumption that for every voltage vector of an alternator, there is a corresponding MMF. Okay, so the MMF which you are going to draw vectors, it will be drawn at a right angle to the voltage vectors. So here we can consider that in the MMF. So the first thing is, like in this IF1 is the field current which is required to produce the voltage. Okay, so IF1, how to get the value of IF1? IF1 will be the value which is going to produce this. So we need to solve this. E1 is equal to V plus I into RA. Then you will get one E1 voltage. Okay. So the E1 voltage, what we will solve now, that whichever the value it is going to intersect with the OCC curve, that gives you the IF1. What about the IF2? IF2 is the field current which is required to produce a rated current on a short circuit. So that is already we have already got that value, single value of a current, no, that is during a short circuit condition. So that IF1 we have to note it down. Okay, sorry, that will be the IF2. IF1, this is how we have to solve. So once you get these two values, then we can substitute to this formula. IF is equal to square root of IF1 square plus IF2 square minus 2 times of IF and IF2 into cos of 90 plus or minus psi. Again, plus is for lagging, minus for leading. So both the cases we have to solve. Then we can get the value of IF. So the corresponding we will get somewhere here. Let us imagine there is a IF here. So corresponding value which is going to intersect with the OCC curve, the value which is meeting to this y-axis, that value will be the E. Okay, so that E should be noted down. That E should be noted down. So we can solve that E naught minus V divided by V into 100. So that is how the challenging is. This is how the E naught can be solved by using the MMF method. So we have to solve the IF formula. Okay, then once you get for the regulation for different values of this power factor, then we can plot this graph. So here this is what the open circuit test and a short circuit test of a given three-phase alternator is conducted, and percentage regulation at a different power factors will be determined by using this EMF and as well as the MMF method. Okay, so usually in the EMF method, we'll get we will get a more value what we are expecting. So that is why we are going to perform the MMF method. Usually the regulation will be less value, right? So we will get the less value compared to that of the EMF method. In the MMF method will be more preferable. Thank you for watching this video.